value of unknown charge, value of unknown charge placed at the center, placed at the midpoint or center of a square, placed at the midpoint of a square containing four equal and like charges, containing four equal and like charges at its four corners, at its four corners, containing four equal and like charges which are placed at the four corners of the square. Four corners of the square. This is a square. This is a square. There are four like and equal charges Q1, Q2, Q3 and Q4 which are placed at four corners of the square ABCD. ABCD are the four corners of the square. ABCD are the four corners of the square. Now we can draw two diagonals. These are two diagonals and the point of intersection, that is the point O, is the center of the square, and unknown charge Q5 equal Q, capital Q is placed at the center O of the square. Let an unknown charge Q5 equal Q be placed at the midpoint or center, be placed at the midpoint or the center O, the midpoint or center O of the square ABCD, of the square ABCD. At equilibrium, the electrostatic force, experienced by any one of the known charges, that is Q1 or Q2 or Q3 or Q4, placed at the four corners of the square ABCD, is zero. That means the electrostatic force or net electrostatic force experienced by any one of the known charge placed at one of the corner of the square is zero. Now F12, F13, F14 and F15 are the electrostatic forces experienced by the known charge Q1 due to the charges Q2, Q3, Q4 and Q5 respectively. Now we can denote the direction of different force experienced by the known charge Q1 equal Q. This is the direction along which F12, that is the force experienced by Q1 due to Q2, is acting. That means this force F12 acts along AY from the point A with respect to the charge Q2 equal Q. F14 acts along AX. F14 is the force experienced by the charge Q1 equal Q due to the charge Q4 equal Q at the point D. Similarly, we can denote the direction of other two forces experienced by the charge Q1. Along this extended diagonal direction, along this extended diagonal direction, the force F13 acts. F13 is the force experienced by the charge Q1 due to the charge Q3. Similarly, we can denote the direction along which the another force, that is F15, will act. F15 will act. This is the direction along which the force experienced by Q1 due to the charge Q5, that is F15, will act. And this force is F15. This force is F15 which acts along this direction. Therefore, F12 equal 1 by 4 pi epsilon 0. 1 by 4 pi epsilon 0 q1 q2 divided by ba whole square equal 1 by 4 pi epsilon 0 q1 dot q2 divided by L square. Since AB is equal to L, which is length of the square, equal 1 by 4 pi epsilon 0 q into q by L square. Finally, we get F12 as equal 1 by 4 pi epsilon 0 q square by L square. F12 equal 1 by 4 pi epsilon 0 q square by L square. This is the electrostatic force. Experienced by the charge q1 at the corner A of the square ABC, experienced by q1 due to another charge q2 at the corner B. And this force acts away with respect to the charge q2. This force acts away with respect to the charge q2 and it acts from the point A. In this case, the charge q1 equal q at the corner A experiences a force F12 due to the charge q2 equal q at the corner B of the square. And this force F12 acts along the direction AY, and F12 equal 1 by 4 pi epsilon 0 q1 q2 by BA whole square. As this force F12 acts along AY, that's why distance should be BA. Similarly, F13 will have the same expression, that is 1 by 4 pi epsilon 0 q1 q3 divided by CA whole square. Q1 q3 divided by CA whole square, not AC whole square, it should be CA whole square, equal 1 by 4 pi epsilon 0 q square divided by root 2L whole square. Since AC is equal to root over AB square plus BC square is equal to root 2 times of L. AC is the diagonal, which is root 2 times of L, where L is the length of each side of the square. And in this case, F13 should be 1 by 4 pi epsilon 0 q1 q3 divided by CA whole square, because F13 acts parallel to the direction CA. So finally we get F13 as equal 1 by 4 pi epsilon 0 q square by 2L square, which acts away with respect to q3 and from the point A. Again, F14 is equal 1 by 4 pi epsilon 0 q4 q1 divided by R square. Q4 q1 divided by R square divided by L square, that is 1 by 4 pi epsilon 0 q square by L square, which acts away with respect to the another charge q4 and from the point A. That means F14 acts along AX prime. Similarly, F15 is equal 1 by 4 pi epsilon 0 q5 q1 divided by OA whole square divided by OA whole square. Therefore, F15 is equal 1 by 4 pi epsilon 0 capital Q small q divided by L by root 2 whole square. Since OA is equal to AC by 2, that is L by root 2 whole square. Therefore, F15 equal 1 by 4 pi epsilon 0 capital Q small q 2q divided by L square, 2 capital Q small q divided by L square, which acts away with respect to the charge q5 and from the point A, which acts away with respect to the charge q5 and from the point A. The resultant of the two forces F12 and F14 is given by Also, we can write F14 is equal to F12. So the resultant of F14 and F14 and F12 is given by F124 is equal to root over F12 square plus F14 square plus 2F12 F14 cos 90 degrees, since that two forces are perpendicular to each other. At the point A, we can denote the direction, two mutually perpendicular direction AY and AX prime. Along AY, F12 is acting. Along AX prime, F14, the force F14 is acting. Now we can consider a parallelogram containing F12 and F14 as two adjacent sides. Along this diagonal, the resultant F124 will be acting. Along this diagonal, the resultant F124 will be acting equal root over F12 square plus root over F12 square cos 90 degree, since F12 is equal F14. So finally we get F124 as equal to root 2 times of 1 by 4 pi epsilon 0 q square by L square. F124 is equal to root 2 1 by 4 pi epsilon 0 q square by L square, which acts in the same direction as that of F13 and F15. F124 acts along a direction which is the same direction along which F13 and F15 are acting. Therefore, the resultant of these three forces which are acting along the same direction is given by, that means the resultant of F13, F15 and F124 is given by F1 equal F13 plus F15 plus F124. Therefore, F1 equal 1 by 4 pi epsilon 0 capital Q dot small q q square by 2 L square plus capital Q small q by L square root 2 small q square by L square. F1 is equal 1 by 4 pi epsilon 0 under bracket q square by 2L square plus 2q by L square plus root 2q square by L square. At equilibrium, F1 equals 0, that is total electrostatic force experienced by the charge Q1 at the corner A is equal 0. Therefore, F13 plus F15 plus F124 equal 0. Or 1 by 4 pi epsilon 0 is taken common, q square by 2L square plus 2q by L square plus root 2q square by L square equal 0. Or q square by L square is taken common. Here q by L square is taken common. Here we get q under bracket q by 2 plus 2 capital Q plus root 2 small q equal 0. Or small q by 2 plus 2 capital Q plus root 2 small q equal 0. 2 capital Q equal minus q by 2 minus root 2 q. 2 capital Q equal minus q by 2 is taken common under bracket 1 plus 2 root 2. Now in the diagram we can denote the direction of the force F124. This is the direction along which F124, that is the resultant of F12 and F14, which is F124 acts. F13, F15 and F124, all the three forces are acting along the direction AZ. That's why resultant of these three forces is F1, which is what F1 equal F13 plus F15 plus F124. That is the resultant force experienced by the charge Q1 at the corner A. We can denote the direction of the force F124, or capital Q equal minus Q by 4 under bracket 1 plus 2 root 2. Capital Q equal minus Q by 4 under bracket 1 plus 2 root 2. This is the value of unknown charge. The value of unknown charge at the center at the center O of the square ABCD containing four equal and like charges at its four corners ABCD at equilibrium. Capital Q equal minus Q by 4, 1 plus 2 root 2, and which is the unknown charge at the center of the square at equilibrium.